So let's look at refer to the origin O. Point A and B have this position vector A and B respectively. Let C be a variable point vector of A minus B. Show that the area of ABC is independent of lambda. Okay, great. I think we're gonna write a few things there. C. We are given that C a variable point, so C, write this down. C is equals to lambda A minus B. Okay, in other words, OC is just this. Alright. Show that the triangle ABC. So I'm going to draw a triangle ABC here and try and understand what's going on here. This is A and this is B. And this is C. We know that the normal convention is being used, so OA is A. OB is also B, right? So the question now is show that ABC is independent of lambda. So it doesn't matter area of triangle ABC. You can actually use any two adjacent sides, two neighboring sides. So you can just use half AB cross AC, or you can use half BC cross BA, or you can also use, it really doesn't matter which one you use because you still get the same answer. Okay, you can also use AB or half CA cross CB. Okay, it really doesn't matter. So if you are using the first one, second, or third one, so you can use the first one if you want to use second or the third, but the first one seems to be easier, so I'm going to use the first one. So area of triangle ABC should be half AB cross AC. So this one is half. We're going to use B minus A for A to B, and C will just be OC, which is actually just lambda A minus B minus A. Okay, so this is this over here is just OC minus OA. Minus OA. Okay, that's a C minus. So the next thing is actually we just gonna slowly expand this out. So half cross this over here. It looks difficult, right? So I could just maybe I could just distribute this in. Okay, so I slowly do this lambda B minus A. Okay, maybe I just do this B minus A cross with lambda A minus B minus B minus A cross with A. Okay, this is pretty okay. Once done. Now once this is done, just take note, this is A minus, this is B minus A. You can actually just factorize the negative out. So I'm going to factorize the negative out. And this lambda can move, because lambda is a constant, so we can just move to the front. So on this one here, I'm just going to bet this is lambda minus lambda, and this will be A cross B cross with A cross B. A minus, sorry, I factorize the negative out. Will be A minus B cross with A minus B. Okay, you can just leave it like that. Then first for this one here, I'm gonna distribute it in, so it's B cross A minus A cross A. Okay, there you go. So I just distribute this in. The order matters, so just take note that if this is A is behind, so this is B cross A, then this is A cross A, right? So anyway, this will be zero vector because any vector which cross itself will be 0. A minus B cross A minus B will just be a zero vector. Okay, this will also be a zero vector, so that's pretty okay. I write this down. This will just be half minus lambda zero vector minus B cross A zero vector, and that will be half. Okay, and this B cross A modulus will be, you can just flip the sign and be A cross B as such. Okay, there you go. So the area of hence area of triangle ABC is independent of lambda, because lambda is nowhere shown in the area here. Okay, nowhere in this equation that we found. So it's the area of triangle ABC is just half A cross B modulus. That's all. So that's how you do this question here proficiently. If you have any questions at all, please let me know, and I'll see you in the next question.